Hello everyone. So in this video we are going to implement the face mesh feature of Mediapipe. The aim of the video, however, will be to actually understand the different landmarks and also to see how they are organized so that we can use them in our own projects. But before I start coding, I would ask you to please subscribe to my channel and also hit the like button. Okay, so we'll first start by importing the basic libraries. So we'll import Mediapipe as MP, CV2 and NumPy. Okay, now let's load the image using the cv2.imread function. In my case, I had to resize the image because the image was too large, so I have resized it to 600 x 600. Next, we will write the name of the class that we will be using to find the landmarks on the image. Now I'm not going to write the drawing functions of Mediapipe right now because we'll be making them as our own. But before drawing, I have to show you some very important things that are actually important if you are wanting to implement your own face mesh or a project that uses faces, and that is how we interpret the 478 landmarks that the Mediapipe face mesh provides. So the first thing we do is to assume a variable connections_irises and assign it the value mp_face_mesh.facemesh_irises. If you print connections_irises, you get a frozen set with pairs of numbers in each, as you can see here. Now, what do these numbers represent? These numbers are the indices which corresponds to the irises feature. As you can see that we have printed 471 as one of the numbers. What it means is that the 471st index in the list of 478 elements belong to some landmark in the iris. In output, you can see that 471 and all other numbers appear twice. So if you take the unique numbers only, you get the indices of irises. And if you have not counted them already, I'll tell you that there are 8 unique numbers, as there are 8 landmarks in the irises, and you can also see the counting on this image. Now you may think, okay, why are these numbers arranged in pairs? Well, the answer is that they are representing the connections. So as you can see that 471 and 472 appear in a pair, which means that there is a connection or a line between the landmarks at index 471 and the landmark at index 472. And similarly, you can see for other pairs of points also. Now let us quickly get the unique points by writing a function get_unique and passing in the connections of irises as the parameter. Now define the getUnique function and have C as the connections. Then convert the connection to a list. After that, assume an empty set as temp set. The reason we are using a set is because we are interested in finding unique numbers from the pairs that we have seen earlier. Then for every t in temp list, we will add the first element of the pair. Then we will also add the second element. Lastly, we will return the temp set as a list. Now if you print the indices of landmarks that correspond to irises, we get 8 unique numbers as you can see here. Then let's see for the face oval also. The face oval are the corner landmarks in red as you can see here, and if you find the connections and print it, we get this. As you can see, there are 36 pairs of points. Then we can find the unique points using get_unique function and pass connections of face_oval as parameters, and we get these 36 unique indices. If you print all of these on the image, you get the numbers as you can see here. You can see here that the numbers are not in any specific order, like clockwise or anti-clockwise. But trust me, it does not affect anything, and so we will just let that be. Okay, now we can actually start finding the landmarks for the image, and for that we will instantiate the facemesh class and pass in some parameters. The first parameter that we pass is the static_image_mode, which basically asks whether to detect faces in every frame of the video or not. Since we have only one frame, that is our image, we will keep it to false. So if we were to use a video instead of an image, we would have kept it to true. If this parameter was set to true, then the face detection module would have been called for every frame. But since the parameter is set to false, the faces and the landmarks, that is the 478 points, are found, and then the algorithm will just track these points and not detect the face again. This is true for all the faces that we want to detect in an image. The second parameter actually deals with the maximum number of faces that we want to detect in an image. I have set it to 2, but you can definitely have a higher number. The third parameter is define_landmarks, which is using another model to get more precise and defined landmarks in and around the region of eyes and lips. We'll keep it to false. Lastly, we will have the min_detection_confidence, which is prompting the model to only detect and show a face if it is more than 50% sure that there exists a face. So in the case the model is highly sure of a face that is more than 50%, it will show, or else it will not show. We then initialize it with the variable face_mesh. And now we are ready to find the results for the faces. There is still one more thing to do, that is to make a copy of the original image. The reason we have made a copy is because we don't want to make the changes that we make on the new file to actually reflect on the original image file. Now we are ready to invoke the facemesh algorithm. We will use the process function of facemesh and pass in the image, but the format will be RGB and not the BGR format of OpenCV. The reason is CV2 uses the BGR format for image, but Mediapipe uses the standard RGB format. We will then save the output in the results variable. Now, if you just print results.multi_face_landmarks, we get a list. The list right now has just one element. So results.multi_face_landmarks has as many elements as there are number of detected faces. And so if we use this image, we will have two elements as there are two faces. These elements in the list are actually the landmark coordinates of the faces, which are 478 in number. Now we take a for loop and we will save the details, that is the landmarks of every face, in the variable LMS. So if we print LMS variable, we see the landmarks in the list form. Now we define an empty dictionary for reasons that you will see in a second. So let's say we now have to find the coordinates of all the landmarks in the face oval only. So we will open a for loop and iterate for every index in face_oval_indices. If you don't remember the face oval indices, they were 36 in number and each represented one landmark in the face oval, which you can see here. Now if we just print the landmark values at the indices, we will get 36 outputs. As you can see, all 36 elements have X, Y and Z for each of these 36 face oval landmarks. We can see that X, Y and Z are all less than 1, which basically means that these coordinates are normalized with respect to the image dimensions. What I mean by that is, let's take the first index, and the landmark it points to is this one in the image, as you can see here. The way I got the real X coordinate is by multiplying the normalized X coordinate by the width of the image, and for Y we multiply the normalized Y coordinate with the height of the image. The Z coordinate has to do with the depth and we don't need it right now. So to find the real X coordinate of the landmark, we write X equal to int of LMS index.x into image.shape of 1, and similarly for the Y coordinate. Lastly, we save the coordinates in the dictionary so that we can use it during the drawing time. Now let's start drawing the points on the image. For that, again start a for loop, and for every index we use cv2.circle function and pass in the black image, which are defined in a second. We also specify the center of the circle and the radius, the color which is going to be green, and the thickness -1, which is basically used to fill the circle. Before printing our result, we will define black at the top just as a numpy tensor of the shape of image and having the type as uint8, which is used in images. So if you run the program till here, you can see the points in green and the face oval is outlined. Instead of black, you can use the annotated image that we have defined earlier and have the same output on the real image. Okay, now let's draw the connections. So again, we have a for con in list connections face oval. If you remember, it is the connections that we got initially, and now we can use them to draw the lines between the dots. Then we can use the cv2.line function and pass the black image and define the starting and end coordinates of the line, which are basically the starting point and the ending point. We also pass the color as red and thickness of 1. Then at last we display the final image using cv2.imshow, and you can see the results here. Now if you are interested in irises, you just need to change the face oval indices to iris indices in both the places. Then you need to change the connections face oval to connection irises and get the output as you can see here. Now we are done with the images, and let's start with the video. As I mentioned earlier, we don't have to make many changes, so we just copy paste the image code, and instead of reading the image, we read the video capture. I have used the video that you can see here, and there are two of them, and their names are vid.mp4 and vid1.mp4. We will delete the black variable from here, and in here we'll write a while loop to check if the capture is opened or not. We will also select everything below and send it to the right one step by pressing Ctrl and right square bracket key. But first, we need to read the frame and check whether the frame we read is true or not. And if it is false, we break. After that, almost everything remains the same. We find the result, then we find the x and y coordinate, add a black image and draw the points and connections. Now at the last, we just write the code for wait key and at the end release the capture and destroy all windows. So if you run the program, we get our results. And as you can see, we got the face oval coordinates and connections on the black frame. For drawing on the real image, use the annotated image instead of black and we get the results on the annotated image. So the code is available on GitHub. Type datum coding face mesh Mediapipe to access it. Please subscribe to the channel and thank you very much.